Alright, before we get started with problem number 5, I promised you I'd show you more pictures of my dog. So here she is, lying down, looking like the cutest little thing ever. She has an eye booger right there, if you see it. Maybe I'll go clean that for her. But she's so stinking cute. Look at this one as well. I took another shot to show you how absurdly long she is. Look how long that dog is. That's crazy. She's like at least, oops, let's say. She's like what? What is that? She looks like a cylinder apparently. And she's about 8 feet long. Somewhat of what I said may not be factual, but anyways, let's do problem number 5. State the domain in both interval notation and set boulder notation, and state the zeros of the function given y equals root 3x plus 1 minus 2 over 4x cubed minus 36x. Gross. Well, let's do zeros first. So, if you're dealing with a fraction function, a rational function, something with a numerator and a denominator, the zeros will happen when the numerator is equal to 0. So whatever x values make the numerator equal to 0 will give us zeros. I don't know how to say it. So, when is the square root of 3x plus 1 minus 2, when is that equal to 0? Well, just solve for x, and then you'll know. So square root of 3x plus 1 equals a 2. Okay, now what? Well, square both sides. So 3x plus 1 equals 4. 3x equals 3. X equals 1. So x equals 1 is a solution. It is a 0 of this function. And think about why that makes sense. We want this numerator to be 0, and ignore all that stuff. We have a minus 2 at the end, so we need the square root of 3x plus 1. We need that to give us 2 when we're finished. Well, if we want the square root of something to equal 2, what does that something have to be? Square root of what gives you 2? Square root of 4. So 3x plus 1 has to equal 4. So x has to equal 1. I don't care how you get there, as long as you get there. So x equals 1 has to be a 0. How do I want you to write that? Just say 0 at x equals 1. If you wanted to be cool, well, nope, I didn't give you a function notation. Whatever, leave it at that. 0 at x equals 1. Okay, well, what else? What about our domain? Well, domain, a couple things we need to think of here. The most obvious thing to think of is when is the denominator equal to 0? Because when the denominator is equal to 0, we are going to get a 0 in the bottom of a fraction, which is undefined. We cannot include those x values in our domain. Remember, where undefined things found? Under there. Undies. Under there. Under the bottom. Under the fraction. At the bottom of the fraction. So let's factor 4x cubed minus 36x. Let's pull out a 4x. What are you left with? Well, 4x times what is 4x cubed? Well, 4x times x squared is 4x cubed. 4x times what is negative 36x? Well, 4 times what is negative 36? That's negative 9. And that's that. So 4x times negative 9 is negative 36x. But we're not finished yet. 4x times x squared minus 9 is a difference of squares that will factor as x minus 3 and x plus 3. So when is this denominator equal to 0? Well, it's equal to 0 when x is 0, from that guy right there. Is equal also to plus or minus 3 from that and that right there. But that's in the denominator. These are not zeros. These are values that our function cannot have. So x cannot equal 0 or plus or minus 3. What does that 4 do? Well, nothing in the sense of affecting our domain or the zeros. So, whatever. There's that. And you might be like, cool, I'm finished. But you're totally not, because of this 3x plus 1 right there. What do you know about a square root? you know that you cannot put a negative into a square root. So we need 3x plus 1 to be greater than or equal to 0. Yeah? Yeah. So solve it for x. 3x is greater than or equal to negative 1. X is greater than or equal to negative 1/3 right there. So let's put this in interval notation. X, why can't I write? Boom. There's a weird thing. Okay. X in R such that, let's say, x is greater than or equal to negative 1/3 and x is not equal to 0 or plus or minus 3. Scoopoo, right there. What about interval notation? Well, interval notation would be saying x is in the interval starting at negative 1/3. Hey, think about this real quick. If x has to be greater than or equal to negative 1/3, x already can't be negative 3, so we can just get rid of that. It's a little redundant. So let's just say 0 and 3 right there. You feel me? I feel me. So let's go negative 1/3 all the way up to 0, not including it, union with 0 all the way up to 3, not including it, union with 3 all the way up to infinity, not including it because you can't. Finished.